Hello, we are Peacemaker team. I'm Belly, this team's leader. We will present the product that we made during Project B. First of all, we choose the problem about humidity control for drying tea. First, we will talk about the background and outline of the topic we've selected, and then we will talk about the solutions and the principles of the devices and expected effects and feedbacks. First, about overview and background. According to the Indonesia provided problem description, 60 to 70% humidity and 25 to 27 degrees temperature are considered ideal conditions for drying tea leaves. According to the information obtained from mentoring with an Indonesian mentor, there is no device in the local company's workspace that measures the temperature and humidity. Therefore, after analyzing the cause of problem, the hardship of controlling the temperature and humidity was biggest problem cause. Therefore, our team wanted to increase the productivity of drying tea by introducing a temperature and humidity control system and allowing to maintain proper conditions. Here's our solution. Simply put, the device is an IoT system that manages the temperature and humidity of the workspace with the app connected by Bluetooth to the Arduino device. First, I will explain about Arduino device. First of all, there is no device to monitor the temperature and humidity in the area, so we attached the sensor to measure them. The LCD panel displays the current temperature and humidity values of the workspace, so the user can see them. The cooling fans connected through the relay module are programmed to operate when current temperature above the proper value, 27 degrees, and the heater to operate when current value above the proper one, 70%. You can also connect other devices to the remaining channels on this relay module. The product case was modeled for insertion into a drawing bar and was manufactured using a 3D printer. Connect app and devices using the HC06 Bluetooth module for remote control. Secondly, I will explain the application for remote control and monitoring. First, you can see connect button to connect Bluetooth to the device. If device connected, the label that connected turn to connected, and this label displays the current humidity and temperature received from the sensor. By clicking these buttons, each device that connected to relay module starts operating. These labels show each device's state. This is the system that we create by combining the solutions we mentioned earlier. Let's take a look at the operating video. Before viewing, this operating image is not the final version. For the design and testing of the app, we have partially modified the appropriate temperature and humidity values temporarily lower. First of all, if you look at the shape of the device, it has the following shape, which allows the T-rib to be inserted into the drawing bar without taking up any additional space. In addition, a separate half blower heats the air in that space to evaporate water vapor in the atmosphere. As water vapor evaporates, the humidity can be reduced, extending it to a wider range while placing a pan next to the device to prevent a sudden increase in temperature, allowing hot air to circulate. You can observe the decreased humidity of the space as follows. And also, to check this in real time, we use Bluetooth to link it with the app on the mobile phone. Also, when the temperature of the space reaches over 27 degrees, the fan automatically rotated to maintain a constant temperature. Here are the expected effects and feedbacks. This device we built has the ability to remotely control the temperature and humidity, so it will increase the efficiency of your work. It can be monitored through a mobile phone app rather than going direct to the workspace, so you can reduce the time it takes. Also, it does not increase space for the device to be installed, but it inserts into existing bar, so there is no extra cost for space installation. You can also connect other devices to a channel in the relay module for use. Next, we will complete the prototype and explain the conclusion drawn through the feedback time. Because the space in the workshop we researched is small, if you use it in a larger workshop, you will have to install multiple devices, which will be expensive. We also use a hot blow to reduce humidity by evaporating water vapor in the atmosphere, and we use a fan to prevent the temperature from rising rapidly. However, we conclude that some additional devices need to be installed to lower the temperature because this was done with a focus on air circulation rather than on lowering the temperature. So the way we came up with this is to install up the pan and the current together. This will prevent a sharp increase in temperature, so you will be able to control the temperature and humidity more effectively. Also, the sensor may fail due to the temperature and humidity, so it should be checked periodically, and proper voltage should be used in Indonesia to prevent accidents caused by overheating of pop blower. Finally, connecting a new device to the relay module can be difficult for people. To make up for this, I think using these devices in real-world industries will increase productivity and efficiency. Thank you. This was Peacemaker Team.